Good afternoon, everyone. My name is Reshona. I am 16 years old and currently I am studying in class 11. Basically, I have done my schooling from till class 10 from Vidyashil Public School, which was a CBSE school. And now currently I am studying in EMC2, which is a NEET and JEE coaching. I am preparing for NEET 2024 as a NEET aspirant here. Under the guidance of Professor Rohit Sinha and faculty. So basically, the topic that we are going to take today, we are going to take the subtopics of thermochemistry or thermodynamics chemistry. So basically, the topics to be covered are 4 topics: standard Gibbs free energy, enthalpy, entropy, and galvanic cell. So first of all, we'll try to know that what this term Gibbs free energy basically indicates us, or what does it tell us. So Gibbs free energy was basically discovered by an American scientist, Willard Gibbs, in 1890s. He said that the free energy that this term consists is basically the available energy of a system. It basically tells that a system has how much amount of energy. The next thing we are going to see is the difference between Gibbs free energy and standard Gibbs free energy. So the basic difference is that Gibbs free energy is denoted by G and standard Gibbs free energy is denoted by delta G naught. The next thing is that the formula of Gibbs free energy is G plus G is equals to H minus T delta S, where H is enthalpy, T is temperature that we take in Kelvin, and S is entropy. From the formula we can derive its definition such that Gibbs free energy is equal to enthalpy minus the product of temperature and entropy. The SI unit is joules, which is same as energy. And here the formula is delta G naught is equals to minus RT log K equivalent, where R is the universal gas constant, T is the temperature that we basically take in Kelvin, and K is the constant equilibrium constant. So basically K tells us about the concentration of reactant to the product. Now over here, the main difference between both the terms is that in Gibbs free energy, we basically do experiments in which we take the actual temperature, or we do it in an actual temperature or the given temperature. But over here, standard Gibbs free energy, we do the reactions in a standard condition, experimental condition. So basically, we can understand it by this way, that if we take 2 elements and then we try to combine them and make a chemical reaction, so the reactants and the products all are in a standard state. This is known as standard Gibbs free energy. So the standard state can be standard experimental conditions such as standard temperature, which is 25 degrees Celsius. It can be standard pressure, which is 1 bar or 1 atmosphere, and standard concentration, which we take 1 mole. Then basically if we try to define standard Gibbs free energy, so it will be like it basically tells us about the difference of Gibbs free energy in standard experimental conditions. These were the major differences between both the terms. Now if we try to move on to next term, which is enthalpy, denoted by H. It is basically the total energy or total content of heat in a system in which we do all the reactions. So the formula is H is equals to U plus PV, where U is the internal energy, P is the pressure, and V is volume. We can also write it H is equals to U plus W, because we know that pressure into volume is work. This was enthalpy. Also the SI unit of enthalpy is joules, same as energy or erg. Now entropy. Entropy is basically a very interesting topic. We can tell it by that it shows basically the randomness or the disorderness in a system. So when I take 2 elements and then I take some gas or something in them and then I mix them. So basically initially all the entropy was less, but when I mix them, there is a sudden change in the disorderness or the randomness between them. So I can say that the entropy of the system is increased. So now if we take an example of ice or water, or if I take an example of 3 phases such as liquid, solid or gas. So entropy of solid is less than entropy of liquid, and entropy of gas is the highest, because the intermolecular spaces have more space, or they have more randomness or disorderness between them. And over here, if we take ice, so ice has all the molecules very compact to them, so they are stable. They are more stable compared to the water or gas. So it has low entropy, while water has free molecules which are moving here and there, and the entropy will be more. So basically this was between the difference between the two of them. Now if we move on to a very vast topic is voltaic cell or galvanic cell. Now basically this is a spontaneous process in which we do not require any external energy, but what it does is it has a very important significance in our day-to-day or real life. For example, battery that we use in our households. It has two anodes, like a cathode and a anode. So here it is cathode and anode. So basically what it does is the chemical energy converts itself to electrical energy. So here there is a reduction and here there is oxidation taking place. So whatever the electrons are here, they move towards the positive side, which is anode. Now if we take here, it basically the chemical energy, the process is taking between the chemical energies basically transform into electrical energy, which is very useful for us. The formula is G is equals to minus NFE cell, where E is the EMF of cell, F is the Faraday constant, and N is the number of electrons that have been transferred from here to there. So basically this was the subtopics that we were going to learn today, and this from here I just want to thank everyone. So the reference that I used here was the EMC module, which are my coaching modules. Then I have my NCERT textbook, chemistry textbook, and then I have taken some basic informations from Narendra Awasthi. Thank you.